Yeah, so I have to give a presentation after we had an Italian guy explain spaghetti code. So the bar is already too high, right? So yeah, so I won't even try to do any translation on the Chinese, but how many of the local people do you familiar with the stratagems as we have them in our minds today? So everyone in the West knows about Sun Tzu, right? But they don't really know about the stratagems. There's so-called 36 of them. Sorry. But if you're not at my talk yesterday, just a little bit stuff about me. I'm a freelancer, basically. I do consulting around mainly the Europe and the States, and I use heavily Postgres. I come from a very hands-on data engineering background, but I now move everything. I'm in the philosophy of let's move more stuff into Postgres. I've written quite a few extensions which follow the same philosophy of having domain-specific algorithms and very tailor-made specific tools to multiple extensions. So most of my extensions are very focused and very small. They're like 4 or 5 maximum source files, and they solve specific problems. Like you may have seen PGPDF, which is like a PDF data type for Postgres, PDJQ as well. So I know JQ is quite popular both in China and Japan, so maybe you've seen that too. So what are stratagems, right? So I first came across this book a few years back while reading something else, and I spent quite a few dollars because I only could find this in Abe Books. Abe Books was an old Amazon-like website which you'd buy books that are now out of print. So I had found this paperback from this guy from the Netherlands. So the stratagems are basically a collection of 36 of them. So what a stratagem is? An operation or act of generalship, usually an artifice or trick designed to outwit and surprise the enemy. So these are basically, we can see them in all ancient cultures, both in Greece and in Chinese and Egyptians, but from what I know, the Western civilization has never produced something that completed like we have the 36 stratagems, right? So in that book, there's only 18 of them, and I've collected a handful of them, I think 8 or 10 or so, to try to illustrate how one can apply these into data engineering. And mind you that I define data engineering as something very broad, which spans basically from hands-on software engineering to business strategy to data strategy, hence the strategy on its own. But if you're applying the stratagem a strategy in general, you have to first define what's the enemy, right? So enemy from my perspective, and in general what touches what Andrea was talking earlier, enemy is generally complexity, right? So spaghetti code, as Andrea was telling earlier, spaghetti architecture, so you get from point A to point B, you have 2 options. You can go just from A to B, or go to A, D, Z, Y, X, and then back to B, right? So I've just put some screenshot of the book I had there, and then we'll try to illustrate some of them. It's interesting, especially for the locals, to see how each one of those it came to be translated as well. So I was reading the backstory of this one. So I have no idea about diagrams, but I remember this ideogram here in particular. It translates sometimes to emperor and sometimes to heaven. So the author of the book was saying that I came first across this stratagem. I asked 2 guys when I was studying in Beijing, he said, and they all translated this as heaven instead of emperor. So this didn't make sense, right? And then suddenly one out of the blue, he actually translated this as emperor, so the whole thing made sense. Now each stratagem, along the years, it has a different implementation of how this support. In this particular one, I won't recount the whole story. So the basic story is this. There is a Chinese general like a few 100 years back, and he was going to conquer, mind you, I won't even try to mention a single city, but I'll just keep it in general, right? His army was marching towards another city, and suddenly they stopped because there was only sea. right? And the general was, let's say, seasick, or he was afraid to just embark on a journey on a ship for miles and miles ashore. So a smart guy from his army, he says, I have an idea. There's no way we're going back. We just have to move forward. So what we have to do is fool actually the emperor. So what they did, they went on and told him a little lie, right? So, you know, general, don't worry about it. We have a rich guy who is going to actually provide us with supplies to support the query across the sea, right? He says, oh, great. I want to meet the guy. So he goes in, he goes to his place. They have like paintings on the wall and everything, like a normal, very huge place. And suddenly when the emperor walks in, right, the house, let's say, starts to move. And then he suddenly feels a movement, right? And he hears something. And it's already too late for him, but he realized that they're already across the sea. So his army has built a fake city or so, which they put the emperor or the general on top of the floating house as well. So they actually went on and crossed the sea. So the learning here is who's the emperor and who is the sea, right? So the emperor is the CTO and a bureaucracy in our scenario. So if you see someone there's resistance to introduce a new solution or a new status quo, let's say, and your CTO or your business leader or whatever is very afraid to even dip their feet on the water, just push them initially, give them a light push, a light touch, have them initiate a solution, and then as they keep floating, they'll see that it's not that dramatic, right? So in Postgres context the point here is start small, introduce one solution, and then you can port your whole architecture towards it. So the fear that everyone, CTO or business leader is, they think of we have to rewrite this, right? So no one wants to rewrite Oracle or whatever in SQL Server or in vanilla Postgres. So instead they ask for something that is, okay, what's a bridging step I can have? What's a bridging boat I can step on and then go to Azure, IvorySQL in our case. So that's the whole philosophy of just use Postgres as initial step and then moving towards that. The second stratagem I want to reference is BC's way and rescue Zhao, which the point of it is that the state of Zhao was at some point was besieged by some troops from the state away. So instead of just fighting them head to head, the general from Zhao, they said, okay, you know what, let's not face the enemy directly. Instead, have someone, or ourselves even, direct their city, their hometown. So instead of attacking us, they're going to retreat and protect their own city, and then this will save ourselves, right? So it's very typical, very standard artifice, this. So in our case, we can draw an analogy like this one. So if our primary server is under heavy attacks, usually from analytical queries, right? You put something, you say, okay, let's put a standby server. Let's avoid our primary, which is very important for writes, and then push all the analytical queries to the replicas, right? So then we have saved our primary, our hometown, let's say, from the enemy troop, which are the analytical queries, right? So very basic stuff, but it does the job done. Now you have way too many both analytical queries and writing queries, then you have to use something like Patron to have high availability and so on. But the basic idea is there. So build replicas to save your hometown of primary. This is another interesting stuff, which is, I think this from all the stratagems, this is one that you can see across every civilization. To kill with the board now, so sophisticated. In the modern West, we also say this as have someone else do the dirty job for you, or have someone else to do the killing for you. It is said that I think, this one is Confucius. I think hometown was under attack, right? So from another town, and instead of deciding to defend them and oppose them directly, he said, you know what, I can do that. Instead, he convinced another city to attack the city that was attacking his own one. So the other guys had to go protect themselves as well. So he did nothing. He hired another knife to actually do the bidding for him. So in our case, if you have an application, it's very, very typical. Even if you migrate your database, there's a lot of complexity at the application level, especially so when the data model evolves and you have new normalization, new schemas, new tables come into picture. It's very hard, especially if you have even the typical 3-tier architecture, it's very hard to keep track of the schema and actually keep the complexity down as long as your application evolves. This is very difficult because you depend on the front end, you depend on the back end, and so on. And as your Git history increases and evolves, it's very difficult as well to both maintain know-how so that people know what's happening in the database, and it's also very difficult to guarantee, let's say, about the performance of the database as well. So one thing I have found pretty useful is to introduce another API also on top of the database, and you can do that by using SQL functions. So you say what? I have an army of junior developers which I don't trust to write smart enough or performant enough or mature enough queries. So instead, you say, you know what? I'm the more experienced guy, or get a more experienced engineer. You say, don't handwrite queries yourself. Instead, here are the few SQL functions, right? So you get them to do the bidding for you. You have them write a few SQL functions, and you say, and you dictate to the developers, front and back end, basically developers, to say, you know what? Use these functions only. Don't write your own queries. But mind you, you can also do that with things that don't change that often. So you have customer and accounts. Probably your customer fields don't change that much, right? So instead of having different joins being made by the developers, just write them once with SQL functions and have people in database once, right? And have people rely on those. So basically that's the concept of abstracting away the complexity of things. Yeah, this is another typical scenario. I don't have a specific story here for this one, so it's basically referred to soon as well, is that instead of going somewhere and fighting the battle to another's hometown or a neutral ground, just stay there relaxed, pick a site, and then even up on the mountain, and then have the enemy march towards you in an uphill climb as well, right? So whenever they arrive, they are already exhausted for the battle. So in our case, this could be an exhausted database server, right? Or stressing a bit the analogy there. So what you can do that? If you have maintenance that you have to do at some point, you can keep that and do it in low activity periods. What this type of maintenance could do, and mind you, we talk about 3 nines of availability and SLAs and so on, but unless you are no big company doesn't have there's definitely some point that they have low activity periods, right? It could be either Christmas or Saturday morning or Sunday afternoon or whatever. So you can then grab the opportunity and do the basic stuff of vacuuming, never vacuum full as well, right? So except vacuum full. You can do some analyze to get some feedback about your queries, right? Or you can just add indexes, reindex and rebuild the indexes occasionally. So whenever your server is exhausted, then pick up these low pressure, let's say, periods to do some of this stuff. This is another typical which spans across culture, which is when you have a burning house, exploit the chaos, let's say, and then commit robbery, right? So exploit the fire to commit a robbery. Now, this is not an advice we should give to little kids, right? But when you are a grown up, you can certainly exploit some scenarios like this one. So in our case, when you have downtime, take that, because everyone has downtime. So whenever someone has, whoever has at least set up a replica at some point in their life, I'm sure the first 2 or 3 attempts, they did have a split brain scenario happening. So you can take that as a learning. So I remember a couple of weeks back on a project, we had this exact scenario where the learning there was that the guy, the developer, the colleague who set up the replica across the primary they just copy-pasted the PostgreSQL and then something happened on primary. We had a lot of transactions. He went on up on the state of chaos. He switched the parameter in his primary. I think it was maximum transaction logs, I think it was, but they didn't change this on the standby server, right? So it was a bit lower or higher, I think, but if they have to change that, they never did, right? So the learning there is that we did is put up on Confluence, set up a wiki node, and say, you know what, whenever someone changes on primary, they should either notify at least one people that they changed something, or even yet better document it and change it themselves on the secondary as well. So take some time for learning and recovering. That's the looting in our scenario. Then that's another story that's I like, which is clamor, stratagem, right? Clamor in the east, attack in the west. So the story goes there that there was a city which was besieged both from the east and the west. So they were blocked. They didn't know what to do. So they just pretend to actually go north. So they just sent a handful of soldiers marching out of the northern gates with some lights and a few horses. So both the city that were besieging them from the west and the east, they were thinking, oh my God, they're onto something. They're actually going to attack something, right? So maybe they're going to attack our own hometowns, right? So they eventually left, and then the city was free to do whatever. So because they were not besieged anymore, right? So what could be an analogy there is PG bench, right? So you can do simulate some activity and see what happens, right? So there's definitely, whenever someone has designed a schema or set up a primary or secondary server, back at the heads, they do know there's some certain scenarios and some certain queries that they're not really prepared for. So before that happens in practice, you might as well do that yourself and say, you know what, let's see what happens there. What happens if I put like a very huge analytical query with 8 table joins and then a very complex expression and so on, what would happen? So force a reaction on the enemy, which enemy, again, are the queries. And then you can attack from the west, which is actually do the optimization, create the indexes or add index on expression or add materialize views or so on. And then this is another stratagem I pick, which is create something from nothing. An application of this, suppose, mind you, each stratagem has different applications, across millennia. So there is a story there which is, I think it was on the Korean War in the 50s or so. There was, the story goes, cut me some slack here, is that there was a battle between American and Chinese soldiers in a very narrow strait, right? It was a dam, I don't know, or a very a weird mountain or so. So the Chinese soldiers, they were outnumbered by the Americans, which they were throwing too many bombs and too many fires in a very narrow place, right? So this pushed the Chinese soldiers to actually retreat into the mountains in the tunnels, right? And there were only a handful of them. So the nightfall, the Americans was just waiting outside the tunnels. First night went by, nothing happened. Second night went by, nothing happened. Then the Chinese soldiers, they just started doing something very simple, which is basically throw some rocks on the gate. This woke the Americans up, so they were on alert, right? Nothing happened though. Again, the second night, again, they threw some stuff, Americans put on alert, nothing happened, they go back to sleep. And so on. This happened the third night. Now, the fourth night though, they threw something, but the Americans said, okay, nothing happened again, so they fell asleep. So they fell asleep again at the fifth night, but the fifth night, the handful of Chinese soldiers, they just went on the barracks and exploded, they put the fire on the barracks, right? So the point there is that if you grow complacent about something, it's very tiring, very tiresome to actually be on alert all the time. So eventually your resiliency draws out, right? So this year, so they created something out of nothing, right? So in our scenario, the one I have picked is one of my favorite features and aspects of Postgres, which is the JSON-B infrastructure, right? The JSON stuff. So the learning there is you can create schema out of schemaless data. So my favorite feature I think that Postgres had in the last couple of, 3 I think releases is the JSON table implementation. So how many of you have used JSON path or JSON stuff in Postgres? Yeah. So you pretty much know, I guess, what JSON B is. JSON path has been around for at least 3 or 4 major releases. Extremely powerful. It's extremely powerful. So if you know JSON path, and thanks to the PG Pro guys, I see Aliona here, which they have done tremendous work on the JSON B, the JSON path. One of the features we got in PG17 was the JSON table clause. So basically, if you have something like this one, we have some just JSON B stuff and some metadata. The typical way to do it is before PG17 is that we would say, okay, I have my JSON data, I can create a view, create a materialized view, which is very expensive to both maintain, and then pretty much I forget about the schema after I do it at once, right? So you have to revisit the schema, revisit the query, the JSON path, even revisit the manual because JSON path is not that easy to remember. So instead, you can use the JSON table functionality, and you can say, okay, on my table, the my fields, I can specify for each field that I want one JSON path, and this will render this directly as a single table. So the learning there is that you can create from nothing like a schemaless thing. We can actually get a normalized like schema. Of course, you can't have normalized view there, but you might as well just do this a materialized view. So out of schemaless, you got strictly a force schemas from the get-go. And then a similar story to the story we found earlier, which is to fish out, let's say, the snake. You have to just beat the grass, force a reaction for it. So force a reaction in our scenario could be, again, like execute an anomalous query, a very intensive one, anomalous can be either very performant, right, resource heavy in its execution plan, or it can be even a query which has very weird parameters that we don't usually get, right? So you can have stuff like, how does my front end parse non-UTF characters, right? How does a very typical scenario easy bug to have is, how does my front end handle decimals? Could be like, it's one thing to have like 3.8 or 3.8, depending on where the user is based. So in the States, for example, we have like a comma for 1,000 separator. In Europe, we have like dot. Surprisingly, these things, as people pass stuff from JavaScript to the front end, which is very lenient about this stuff, to the back end, like Java and Python or whatever, to the database, it's very easy to have huge troubles there if you don't get careful. So I would suggest, if you have front-end code, just try something like that. Just run a very weird query that's so used like a Greek semicolon, question mark instead of semicolon or whatever. What happens there? You can rattle out a snake at sometimes there. So force it, and then you can see how this affects performance. What are the DBA's reaction, right? So be a little bit sneaky about this. If something happens, how does your DBA react? How does your alerting system work? And of course, does your application has side effects, and does even your backup system works? Does your high availability zone, is it in fact highly available? Or maybe someone from the DevOps team forgot to configure something. Or maybe I stumbled upon this a couple of months ago. I was trying to restore a PG-based backup for a secondary server, and it turns out that everything worked fine except from the S3 bucket, which would actually use to fetch the base backup payload. It didn't work that well, something about the API keys or whatever. So had this happened in a real life scenario without me noticing this, we'd have real trouble. And then another story, another stratagem is borrow a corpse for the soul's return, which I have translated it to basically use seemingly outdated tool with Postgres. For those of you who was at my yesterday talk, I alluded to this, but I'm going to reference this again. There are certain scenarios, especially if you do one-off data engineering stuff, even pipelines, let's call them, that you can stress Postgres probably too much, right? Multi-processing stuff. like queries, and this can block your primary or database. You don't want to do that. So you might as well outsource some of this execution and have it on outside the database, even for one-off, but surprisingly, even for non-one-off queries. So I have seen that something like this as a process works pretty well. So instead of having like an alter table that can lock your whole table into one computation across the whole rows and block writes or whatever, you just pipe it out of the with PSQL, do something with typical set and awk, like pre-processing stuff, like replace or column-oriented stuff, parallelize with XArgs instead of pushing the computation and then using the pool of maximum parallel workers, and then just push the result back to the database. This is ideal if you do one-off. Obviously, you don't want to have like triggers and stuff to use bash scripts. But if you're really into adventurous stuff, there is Peter Eisentraut has created this extension which is called PL Shell, which is amazing. It's an anti-pattern, but still amazing in that you can actually call bash scripts as you do with PL Perl, PL Python. Trust me, it is extremely powerful. Of course, you don't want to do this on a trigger, and then whenever a new row is inserted, you don't want to spawn a bash process interpreter, but you can do very exciting stuff there. And then to catch the bandits, first capture the leader. You can see that hit the snake on the head. You can do things like that. So what's the scenario I've put here is, if the bandits and the bad guys are the queries, there's only one way. Okay, you can either try, you can pray, you can hope that nothing bad happens, but then instead of guessing, you might as well install this beautiful thing here, pdstat statements, right? So the thieves, in our case, the bandits are the very bad, the bad guys are the slow queries. You just install this. It's literally 3 or 4 lines on your pgconf, and then it can tell you everything about who's the bad guy, who's the worst guy of them all. And from what I've seen, it applies the 80-20 Pareto rule. Like almost, if there's something slowing down the database, I've never seen anyone make the correct guess of what is the root cause of the root query that is the slow one. Everyone always guesses something wrong. So the only source of truth there is to use pdstat statements to flash out the actually slow query. So, and then this is how this looks like. I don't use reset that often. Maybe I should do it that often as well. And then you can select the query, how many times it is called, do some basic statistics there, look at the documentation, and you'll pretty immediately spot what are the slow queries. So, and I think that was the last stratagem. So yeah, thank you for your time. I hope you enjoyed it, and reach out if you want to give feedback or any ideas or whatever. Thanks a lot. Thanks a lot.